Hello, my dear stargazers, and welcome back to The Sleep Scientist. I'm so grateful you've chosen to spend this evening with me, settling into your comfortable space as we embark on another journey through the wonders of our universe. Tonight, we're going to explore one of nature's most breathtaking celestial performances, the blood moon, total lunar eclipse. Take a moment right now to get comfortable, whether you're nestled under soft blankets, resting in your favorite chair, or lying peacefully in bed. Allow yourself to settle in completely. Feel your body relaxing as we prepare to journey together through space and time, discovering the gentle mysteries of our cosmic neighborhood, the blood moon. Just hearing those words might conjure images of ancient prophecies, mysterious transformations, or dramatic celestial events. But tonight, we'll discover that while a lunar eclipse is indeed one of the most spectacular shows our solar system has to offer, it's also a beautiful demonstration of the elegant, predictable dance that our Earth, Moon, and Sun perform together in the vast theater of space. There's something profoundly comforting about understanding the mechanics behind what might initially seem mysterious, or even frightening. When ancient civilizations looked up at the night sky and watched their familiar, bright moon slowly disappear into shadow before emerging, transformed into a deep, coppery red orb, they created stories to explain this wonder. Some saw it as a dragon devouring the moon, others as a sign of divine displeasure or impending change. But we have the gift of modern understanding, the ability to see this phenomenon not as something to fear, but as something to marvel at, a perfect demonstration of the orderly, beautiful mechanics that govern our solar system. Tonight, as we explore together, you'll discover that a blood moon eclipse is actually a gentle reminder of our place in the cosmos, a peaceful alignment that occurs with reliable regularity, offering us moments of shared wonder. Picture yourself for a moment standing outside on a clear evening, perhaps in a field away from city lights, or on a rooftop, where you can see the entire dome of the night sky stretching endlessly above you. The air is comfortable, maybe with a gentle breeze that carries the sense of evening, grass, flowers, or the clean smell of approaching night. You're not alone. Scattered around you are other people, families, couples, individuals like yourself, all looking up with the same sense of anticipation and wonder. This is the magic of a lunar eclipse. It's a shared experience that transcends all the boundaries we create between ourselves. It doesn't matter where you live, what language you speak, what you believe, or how old you are. When the moon begins to slip into Earth's shadow, everyone who can see it is witnessing exactly the same celestial event, participating in the same cosmic moment. And unlike a solar eclipse, which is visible only along a narrow path and requires special equipment to view safely, a lunar eclipse can be enjoyed by anyone with a clear view of the moon. No special glasses needed, no complicated equipment required, just your eyes, your curiosity, and perhaps a comfortable place to lie back and watch the sky transform. Tonight, as we journey through the science, history, and wonder of the blood moon total lunar eclipse, I want you to feel that same sense of connection, not just to the cosmos, but to all the humans throughout history who have looked up at this same phenomenon and felt that mixture of awe, curiosity, and peace that comes from witnessing something larger than ourselves. We'll start by understanding exactly what creates this beautiful celestial show. We'll explore why the moon turns that distinctive red color during totality, why eclipses don't happen every month, and how ancient astronomers learned to predict them with remarkable accuracy. We'll travel through time to see how different cultures interpreted these events, and we'll discover how modern science has revealed the elegant mechanics behind the mystery. But most importantly, we'll do all of this at a pace that allows you to truly absorb and appreciate each concept. There's no rush in our cosmic classroom tonight. We have all the time in the universe to explore, to wonder, and to find that deep sense of peace that comes from understanding our place in the grand cosmic dance. As we begin this journey together, I invite you to let go of any stress or concerns from your day, the bills that need to be paid, the emails that need to be answered, the tasks that await tomorrow. All of these can wait. Right now, in this moment, you're part of something much larger and more eternal. You're exploring the same cosmos that has fascinated humans for thousands of years, learning about phenomena that will continue long after we're gone, finding your place in a story that began billions of years ago and will continue for billions more. Take a deep, slow breath with me. Feel the air filling your lungs, carrying with it the oxygen that was once part of ancient stars. The same elements that make up the moon we'll be discussing tonight. Hold that breath for just a moment, feeling connected to the cosmic processes that created everything around you. Then slowly release it, letting go of any tension and settling more deeply into this peaceful exploration. The blood moon eclipse is not just an astronomical event. It's a meditation on time, space, and our connection to the universe. It's a reminder that we live on a planet that moves through space in precise, predictable patterns, accompanied by a moon that has been our companion for billions of years, all of us warmed and illuminated by a star that provides the energy for life itself. Tonight, we'll discover together how these three celestial bodies, Earth, Moon, and Sun, occasionally align in such a way that our planet's shadow engulfs our lunar companion, transforming it from a bright silver disk into something that looks almost otherworldly. We'll learn why this transformation creates that beautiful red color, why it happens when it does, and why humans throughout history have found these events so meaningful and memorable. But before we dive into the mechanics of orbital dynamics and atmospheric physics, let's take a moment to appreciate the simple beauty of what we're about to explore. Somewhere above us right now, even if we can't see it, the moon is following its eternal path around our planet. It's the same moon that has inspired poets and lovers, guided travelers and farmers, marked the passage of time for countless generations of humans and animals. This moon of ours is more than just a rocky satellite. It has been our cosmic companion throughout the entire history of our species. It's influenced our evolution, stabilized our planet's rotation, created the tides that may have helped life move from ocean to land. The moon is so much a part of our earthly experience that it's hard to imagine our world without it, and periodically in a demonstration of the cosmic clockwork that governs our solar system, this familiar companion puts on a show that reminds us that we're all part of something much larger than our individual lives, our daily concerns, our earthly perspective. During a total lunar eclipse, we get to witness our own planet's shadow projected onto the moon like a gentle reminder of our presence in space. Think about that for a moment. When you look at a blood moon, you're actually seeing Earth's shadow. You're seeing the silhouette of your own planet, projected against space onto our lunar companion. It's like the universe is offering us a moment of cosmic self-awareness, a chance to see ourselves from the outside, to understand our place in the grand scheme of things. This is why lunar eclipses have always been so meaningful to humans. They're not just pretty astronomical events. They're profound reminders of our cosmic citizenship, our membership in a solar system, our participation in the grand dance of celestial mechanics that has been going on for billions of years and will continue for billions more. As we settle into our exploration tonight, I want you to carry this sense of wonder and connection with you. Every fact we learn, every concept we explore, every historical story we discover is part of a larger invitation to see yourself as part of this cosmic story, to find peace and perspective in your connection to something eternal and beautiful. The blood moon eclipse is patient and gentle in its revelation. Unlike the sudden drama of a shooting star or the violent spectacle of a volcanic eruption, a lunar eclipse unfolds slowly, giving us time to observe, to understand, to appreciate each phase of the transformation. It teaches us the value of patience, of careful observation, of taking time to really see and appreciate the wonders that surround us. Tonight, we'll learn to see this celestial event through multiple lenses: the scientific lens that reveals the precise mechanics of orbital alignment and atmospheric optics, the historical lens that shows us how different cultures have interpreted and celebrated these events, and the personal lens that helps us find meaning and connection in our shared cosmic experience. We'll discover that understanding the science behind the blood moon does not diminish its wonder, quite the opposite. The more we learn about the precise conditions required for a total lunar eclipse, the more remarkable it becomes that we get to witness such events at all. The more we understand about why the moon turns red during totality, the more beautiful and meaningful that color becomes. Science and wonder aren't opposites. They're partners in the dance of discovery. Knowledge doesn't eliminate mystery. It transforms mystery from something potentially frightening into something beautiful and meaningful. When we understand that a blood moon eclipse is the result of our Earth, moon, and sun aligning in a specific way, we don't lose the magic. We gain a deeper appreciation for the elegant mechanics that make such magic possible. So, as we begin this journey together tonight, bring your whole self to the exploration. Bring your curiosity, your sense of wonder, your desire to understand and connect. Bring your questions and your imagination. Bring your appreciation for beauty and your respect for the complexity and elegance of natural processes. Most importantly, bring your willingness to slow down, to take the time needed to really absorb and appreciate what we're discovering together. In our fast-paced world, it's rare to have the opportunity to spend several hours exploring a single topic in depth, to really sink into understanding something beautiful and meaningful. Tonight is that opportunity. The blood moon eclipse is waiting for us to discover its secrets, to appreciate its beauty, to understand its place in the grand cosmic dance. It's a patient teacher, willing to reveal its lessons to anyone who takes the time to observe and learn. Tonight, we're accepting that invitation to learn, to wonder, and to find our place in the beautiful story of the cosmos. Let's begin our journey together into the gentle mysteries of the blood moon, total lunar eclipse, exploring with the curiosity of scientists, the appreciation of poets, and the peace of those who know they're part of something infinitely beautiful and endlessly fascinating. As we settle more deeply into our cosmic exploration, let's begin by understanding exactly what we mean when we talk about a lunar eclipse, and why some eclipses create that mysterious, beautiful red coloration that gives us the term blood moon. Imagine you're sitting in a comfortable chair in your living room on a sunny afternoon. The sun is streaming through a window behind you, and you notice your shadow cast on the wall in front of you. Your body is blocking the sunlight, creating an area of darkness, your shadow, on the wall. This simple, everyday phenomenon is exactly what happens during a lunar eclipse, just on a cosmic scale. In the case of a lunar eclipse, Earth takes the role of your body, the sun provides the light source, and the moon becomes the wall where the shadow is cast. When the Earth moves directly between the sun and the moon in just the right way, our planet blocks the sunlight that normally illuminates the moon, casting Earth's shadow across the lunar surface. But here's where it gets beautifully interesting, and where the gentle science begins to reveal something truly wonderful. Unlike the sharp dark shadow you might cast on your living room wall, Earth's shadow has layers, subtle gradations that create different phases of the eclipse, and eventually lead to that magnificent red coloration we associate with a blood moon. Let me paint you a picture of how this works, and as I do, I want you to imagine yourself floating peacefully in space, looking down at this cosmic dance from the perfect vantage point to see everything unfold. Picture the sun first, our magnificent star, a sphere of nuclear fusion, producing an almost unimaginable amount of energy every second, sending light and warmth streaming out in all directions through the solar system. This light travels the 93 million miles to Earth in just over 8 minutes, illuminating our planet and continuing on into space. Now visualize Earth, our beautiful blue and green home, spinning gracefully on its axis as it orbits around the sun. Earth is much smaller than the sun, but because it's so much closer to us, it appears large enough from our perspective to block sunlight when it passes between us and our star. When Earth blocks sunlight, it creates a shadow that extends out into space behind it, away from the sun. This shadow isn't a simple dark cone, though. It's more complex and beautiful than that, with two distinct regions that astronomers call the umbra and the penumbra. The umbra is the darkest part of Earth's shadow, the region where Earth completely blocks the sun's light. If you were standing in the umbra, you wouldn't be able to see the sun at all. Earth would be completely covering it. The penumbra is the lighter part of the shadow, where Earth only partially blocks the sun's light. From the penumbra, you would see part of the sun peeking around the edges of Earth. Think of holding a ball between a lamp and a wall. The shadow the ball casts is not uniformly dark. There's a darker area in the center, where the ball completely blocks the light, and lighter areas around the edges where only part of the light is blocked. Earth's shadow works the same way, just on a vastly larger scale. Now here's where the moon enters our celestial story. Our lunar companion is following its own path around Earth, taking about 29.5 days to complete one full orbit. Most of the time, the moon's orbit carries it above or below Earth's shadow, so it continues to receive direct sunlight and appears bright in our sky. But occasionally, and this is the key to understanding why lunar eclipses don't happen every month, the moon's orbital path carries it directly into Earth, his shadow. When this happens, we get to witness one of nature's most beautiful astronomical events. The eclipse begins when the moon first encounters the edge of Earth's penumbra. At this stage, the change is so subtle that many people don't even notice it happening. The moon appears just slightly dimmer than usual, as if someone has turned down a cosmic dimmer switch just a notch or two. This is the beginning of what astronomers call the penumbral phase of the eclipse. As the moon continues along its orbital path, it moves deeper into the penumbra, and the dimming becomes more noticeable. The bright, silvery appearance of the full moon begins to take on a slightly darker, more subdued character. It's still clearly the moon, still recognizably bright, but there's something different about its appearance, something that makes careful observers pause and take notice. Then comes the moment that eclipse watchers wait for. The moon begins to enter the umbra, the darkest part of Earth's shadow. This is when the eclipse becomes dramatic and unmistakable. It starts as a small, dark bite taken out of one edge of the moon, as if some cosmic entity is slowly eating our lunar companion. But this isn't a random or chaotic process. The bite grows larger at a steady, predictable rate as more and more of the moon moves into Earth's shadow. Watching this happen is like watching a masterpiece being painted in slow motion across the sky. The curved edge of Earth's shadow becomes visible as it creeps across the lunar surface, and for the first time, we get to see the actual shape of our planet's shadow projected onto the moon. This is one of the most profound moments of any lunar eclipse. The realization that what you're seeing is your own planet's shadow. You're looking at the silhouette of Earth, cast by sunlight onto the moon. In a very real sense, you're seeing your home planet from the outside, getting a perspective on Earth that's normally impossible to achieve. As the umbral phase continues, more and more of the moon disappears into shadow. But something wonderful is happening even in this apparent disappearance. The moon doesn't simply vanish or turn completely black. Instead, it begins to take on a reddish color, sometimes described as copper, rust, or deep orange. This is where the term blood moon comes from, and understanding why this happens reveals some beautiful physics. The red color of a totally eclipsed moon is caused by Earth's atmosphere, that thin layer of gases that protects and sustains all life on our planet. When sunlight hits Earth's atmosphere, something magical happens. The atmosphere acts like a giant lens, bending or refracting some of the sunlight around the edges of our planet. But here's the key. Earth's atmosphere doesn't bend all colors of light equally. Blue light, with its shorter wavelength, gets scattered away by particles and molecules in the atmosphere. This is the same process that makes our sky appear blue during the day and creates those beautiful red sunsets. Red light, with its longer wavelength, can travel much farther through the atmosphere without being scattered. So when sunlight passes through Earth's atmosphere during a lunar eclipse, most of the blue light gets filtered out, but the red light continues on. getting bent around the edges of Earth by our atmosphere's refractive properties. This red light continues traveling through space and eventually reaches the moon, illuminating it with a soft, reddish glow. Think of it this way: during totality, the moon is being illuminated by all the sunrises and sunsets happening on Earth at that moment. Every place on Earth where the sun is rising or setting is contributing some of that beautiful red light that travels through our atmosphere, bends around our planet, and reaches the moon. This means that the blood moon's red color is actually a gift from Earth, its atmosphere, the same atmosphere that gives us breathable air, protects us from harmful radiation, and creates the beautiful colors of sunrise and sunset. The red moon is being painted by light that has traveled through the atmosphere that sustains us, creating a direct connection between the air we breathe and the celestial show we're witnessing. The intensity, an exact shade of red during totality, can vary significantly from one eclipse to another, and this variation tells us something about the state of Earth's atmosphere at the time of the eclipse. A very clear atmosphere, with little dust or pollution, will allow more light through, creating a brighter, more orange-colored eclipse. An atmosphere with more particles, perhaps from volcanic eruptions, dust storms, or human activity, will filter out more light, creating a darker, deeper red eclipse, sometimes so dark that the moon nearly disappears entirely. This variability makes each lunar eclipse unique and special. No two eclipses look exactly alike, because no two moments in Earth's atmospheric history are exactly alike. The blood moon you witness is a snapshot of our planet and its atmospheric conditions at that specific moment in time. A cosmic weather report painted across the face of our lunar companion. During totality, the period when the moon is completely within Earth's umbra, this red coloration is at its most intense and beautiful. The moon appears to hang in space like a glowing coal, a soft red lantern against the dark sky. Stars that were invisible when the moon was bright become visible around the eclipsed moon, creating a scene of stunning beauty that has inspired humans for thousands of years. But totality doesn't last forever, depending on the specific geometry of the eclipse. How centrally the moon passes through Earth, its shadow totality, can last anywhere from a few minutes to over an hour. The moon continues along its orbital path and eventually begins to emerge from Earth's umbra on the other side. The emergence happens in reverse order of the entry. First, a bright sliver of normal moonlight appears at the edge of the red disk as part of the moon moves back into direct sunlight. This first flash of bright light can be startling. After the gentle red glow of totality, it's like someone suddenly turning on a bright light in a dimly lit room. As more of the moon emerges from the umbra, the bright portion grows while the red portion shrinks. The contrast between the bright white part of the moon in direct sunlight and the red part still in Earth, its shadow creates a striking visual effect, sometimes described as looking like a cosmic eye or celestial jewel. Eventually, the moon completely exits the umbra, ending the most dramatic part of the eclipse, but the show isn't quite over yet. The moon continues through the penumbra for a while longer, gradually returning to its normal brightness as it finally exits Earth's shadow completely. The entire process, from first contact with the penumbra to final exit, can take several hours. It's a slow, stately dance that unfolds at nature's own pace, giving observers plenty of time to appreciate each phase, to understand what they're seeing, and to feel that deep connection to the cosmic processes that govern our solar system. What makes this entire process even more remarkable is its predictability. Unlike weather, which can surprise us, or earthquakes, which can happen without warning, lunar eclipses can be predicted with extraordinary accuracy, hundreds or even thousands of years in advance. Ancient astronomers, working with nothing more than careful observations and mathematical calculations, learned to predict eclipses with remarkable precision. This predictability is a testament to the orderly nature of our solar system. The orbits of Earth and Moon are so regular, so consistent, that we can calculate exactly when they'll align to create eclipses far into the future. It's a beautiful reminder that beneath all the apparent chaos and unpredictability of life, there are deep patterns and structures that govern the universe with mathematical precision. The blood moon, total lunar eclipse, is thus both a spectacular show and a gentle lesson in cosmic order. It demonstrates the reliable, predictable nature of celestial mechanics, while creating moments of breathtaking beauty that connect us to something larger than ourselves. As we continue our exploration tonight, we'll delve deeper into the specific mechanics that make these eclipses possible, understand why they don't happen every month, despite the moon orbiting Earth regularly, and discover how ancient cultures interpreted these events before they understood the science behind them. But for now, take a moment to appreciate the elegant simplicity of what we've discovered. A lunar eclipse is Earth has shadow cast upon the moon, and the beautiful red color comes from sunlight filtered through our own atmosphere. It's our planet's way of painting our lunar companion with the same light that creates our sunrises and sunsets, creating a direct visible connection between the world we live on and the cosmic dance we're all part of. Now that we understand the basic mechanics of how Earth's shadow creates a lunar eclipse, and why the moon turns red during totality, let's explore the more intricate details of celestial alignment that make these events possible. This is where the gentle precision of orbital mechanics reveals itself, showing us how the cosmos operates like an incredibly sophisticated clockwork mechanism. Take another comfortable breath with me as we dive deeper into this cosmic choreography. Imagine you're still floating peacefully in space, but now you have the ability to see the orbital paths of Earth and Moon mapped out before you like glowing trails in the darkness. These aren't random wanderings through space. They're precise elliptical paths governed by the fundamental forces of gravity and momentum. To truly understand why lunar eclipses happen when they do, and why they don't occur every month, we need to appreciate the three-dimensional nature of these orbits. It's tempting to picture the Moon orbiting Earth in the same flat plane that Earth orbits the Sun, like a simple two-dimensional diagram in a textbook. But reality is more beautifully complex than that. Earth orbits the Sun in what astronomers call the ecliptic plane. Imagine a giant, invisible disk with the Sun at its center, and Earth traveling around the edge of this disk. If the Moon orbited Earth in exactly this same plane, we would indeed have a lunar eclipse every month whenever the Moon passed behind Earth relative to the Sun. But the Moon's orbital plane is tilted about 5 degrees relative to Earth's orbital plane around the Sun. 5 degrees might not sound like much. It's less than the width of your thumb held at arm's length against the sky. But in the vastness of space, this small tilt makes an enormous difference. Most of the time when the Moon is in the full moon position, that is when Earth is between the Sun and Moon, the Moon passes either slightly above or slightly below Earth, his shadow, because of this orbital tilt. The Moon receives direct sunlight and appears as the bright, familiar full moon we know and love. No eclipse occurs because the celestial alignment isn't quite perfect, but twice, during each of the Moon's approximately 18.6-year cycle, something beautiful happens. The line where the Moon's tilted orbital plane intersects Earth's orbital plane around the Sun. Astronomers call this the line of nodes, aligns with the Earth-Sun line. When this happens, the Moon can pass directly through Earth's shadow, and we get our lunar eclipse. This is why lunar eclipses come in groups, or series. When the geometry is right for one eclipse, it's often right for several eclipses spaced about 6 months apart. Then there might be years when no total lunar eclipses are visible from Earth, as the orbital alignment shifts and the Moon passes above or below Earth as shadow during full moon phases. The precision required for a total lunar eclipse is quite remarkable when you consider the scales involved. The Moon is about 384,400 kilometers away from Earth, on average. That's about 30 Earth diameters away. Earth's shadow at the distance of the Moon is roughly 9,000 kilometers across, while the Moon itself is about 3,174 kilometers in diameter. So the Moon fits quite comfortably within Earth's shadow when the alignment is right, but the margins for error aren't enormous. What makes this even more impressive is that both Earth and Moon are moving during the eclipse. Earth is traveling around the Sun at about 30 kilometers per second, while the Moon is orbiting Earth at about 1 kilometer per second. The eclipse happens because these motions are so perfectly coordinated that despite all this movement, the shadow alignment remains stable for the hours it takes for the eclipse to unfold. Think about trying to cast the shadow of a baseball onto a softball, while both balls are moving along different curved paths at different speeds. The precision required for the shadow to hit the target and stay there for an extended period would be extraordinary, yet this is exactly what happens during a lunar eclipse, scaled up to cosmic proportions. The shape and size of Earth, his shadow, also play crucial roles in determining the characteristics of any particular eclipse. Earth's shadow isn't a simple cone. It's more like a double cone, with the darker umbra tapering to a point about 1.4 million kilometers behind Earth, and the lighter penumbra forming a larger cone around it. The Moon's distance from Earth varies during its elliptical orbit, ranging from about 350,500 kilometers at its closest approach, called perigee, to about 406,700 kilometers at its farthest point, called apogee. This changing distance affects how the Moon appears to us, and how it interacts with Earth's shadow. When the Moon is closer to Earth during an eclipse, it appears larger in our sky, and moves more quickly through Earth's shadow, resulting in a shorter, but potentially more dramatic eclipse. When the Moon is farther away, it appears smaller, and moves more slowly, potentially creating a longer eclipse, but one where the Moon might not be completely covered by the umbra. The path the Moon takes through Earth's shadow also varies from eclipse to eclipse. Sometimes the Moon passes right through the center of the shadow, creating a long totality with deep, dark red coloration. Other times, the Moon just grazes the edge of the shadow, creating a shorter totality with brighter, more orange coloration, because it's receiving more filtered sunlight from the edges of Earth's atmosphere. These variations mean that each lunar eclipse has its own personality, its own unique characteristics, determined by the precise geometry at the time it occurs. Astronomers classify lunar eclipses based on how deeply the Moon penetrates Earth's shadow, using a scale that helps predict what observers can expect to see. The atmospheric conditions on Earth at the time of the eclipse add another layer of variability to each event. Earth's atmosphere isn't uniform. It varies in thickness, density, and particle content depending on weather patterns, seasonal changes, and even human activities. During the eclipse, sunlight must travel through a much greater thickness of atmosphere than it does during a normal day as it passes through the limb of Earth, the thin edge of our planet as seen from space. This journey through Earth's atmosphere is what creates the red color we see. but the specific shade and intensity depend on what the sunlight encounters during its passage. A clear atmosphere with little dust or water vapor will transmit more light, creating a brighter, more copper-colored eclipse. An atmosphere laden with volcanic ash, dust storms, or pollution will absorb more light, creating a darker, deeper red eclipse. Some eclipses have been so dark that the moon nearly disappears entirely, visible only as a faint, dark red disk that's difficult to see without optical aids. These dark eclipses often follow major volcanic eruptions that have injected large amounts of particles into the upper atmosphere. The eclipse becomes a cosmic barometer, telling us about the state of Earth's atmosphere at that moment in time. Conversely, eclipses during periods of very clear atmospheric conditions can be surprisingly bright, with the moon glowing like a brilliant orange or copper coin against the dark sky. The variation from eclipse to eclipse is part of what makes each event special and worth observing. Even for those who have seen many eclipses before, the timing of lunar eclipses also connects to deeper cycles in the Earth-Moon-Sun system. Ancient astronomers discovered that eclipses repeat in patterns, with similar eclipses occurring about 18 years, 11 days, and 8 hours apart. This cycle, known as the Saros cycle, results from the complex interaction of 3 different periods: the time it takes for the moon to orbit Earth, the time it takes for the moon to return to the same position relative to Earth's shadow, and the time it takes for the moon's orbit to precess or slowly rotate. The Saros cycle allowed ancient civilizations to predict eclipses with remarkable accuracy, even without understanding the physical mechanisms involved. They recognized the patterns, the cosmic rhythms that govern these celestial events, and used this knowledge for both practical and ceremonial purposes. Understanding these cycles and the mechanics behind them reveals something profound about the nature of our cosmic environment. We live in a solar system where everything is connected, where the gravitational interactions between multiple bodies create complex but predictable patterns that unfold over time, scales ranging from hours to thousands of years. The lunar eclipse is a visible manifestation of these deeper patterns. When we watch the moon slip into Earth's shadow and emerge transformed, we're witnessing the result of gravitational forces that have been shaping the orbits of Earth and Moon for billions of years. We're seeing the cosmic clockwork in action. The same forces that stabilize Earth's rotation, create the tides, and maintain the delicate balance that makes life on our planet possible. This is why understanding the science behind the blood moon does not diminish its wonder. It amplifies it. When we know that what we're seeing is the result of precise orbital mechanics playing out over vast scales of space and time, the eclipse becomes not just a pretty sight, but a window into the fundamental workings of the universe. The red light that illuminates the eclipsed moon has traveled an extraordinary journey. It began in the nuclear furnace at the sun's core, where hydrogen atoms fuse into helium, releasing the energy that powers our entire solar system. This energy traveled outward through the sun's layers for thousands of years before finally reaching the surface and streaming out into space as light. After an 8-minute journey through the vacuum of space, this sunlight encountered Earth's atmosphere, where it interacted with molecules of nitrogen and oxygen water vapor, and dust particles being scattered and filtered and bent as it passed through the thin shell of gases that protects our planet. The red portion of this light continued its journey, curved around Earth's edge by atmospheric refraction, traveling on through space to reach the moon. On the lunar surface, this red light bounced off the ancient rocks and dust that make up our satellite, its landscape, materials that formed over 4 billion years ago when the solar system was young. This reflected light then traveled back through space to reach our eyes, completing a cosmic journey that connects the nuclear heart of our star to the rocky surface of our moon, with Earth's life-sustaining atmosphere playing a crucial role in between. When you see the red glow of a totally eclipsed moon, you're seeing the end result of this extraordinary journey of light and energy through the solar system. You're witnessing a demonstration of nuclear physics, orbital mechanics, atmospheric optics, and planetary geology all working together to create a moment of transcendent beauty. This interconnectedness extends beyond the purely physical processes involved. The same gravitational forces that create the precise orbital alignment necessary for a lunar eclipse also influence the tides in Earth's oceans, the stability of our planet's axial tilt, and countless other phenomena that affect life on our world. The moon itself, which puts on this spectacular show during eclipses, has been instrumental in making Earth a habitable planet. Its gravitational influence helps stabilize Earth's rotation, preventing potentially catastrophic variations in our planet's tilt that could lead to extreme climate changes. The tides created by the moon, its gravity, may have helped early life forms transition from ocean to land billions of years ago. So when we observe a lunar eclipse, we're not just watching an isolated astronomical event, we're witnessing a moment in the ongoing story of cosmic evolution, planetary formation, and the delicate balance of forces that make life possible. The blood moon is a reminder of our deep connection to the cosmos, a visible symbol of the complex relationships that bind together everything in our solar system. As we continue our exploration tonight, we'll discover how different human cultures have interpreted these cosmic connections throughout history, finding meaning and significance in the blood moon that goes far beyond its purely astronomical aspects. But the scientific understanding we've gained provides a foundation for appreciating these cultural interpretations, helping us understand why lunar eclipses have been such powerful and meaningful events for humans throughout our history. As we settle deeper into our exploration of the blood moon eclipse, let's take a gentle journey through time and across cultures to discover how different civilizations have interpreted these mysterious celestial events. The stories humans have told about lunar eclipses reveal as much about ourselves as they do about the cosmos, showing our eternal desire to find meaning and connection in the natural world around us. Picture yourself sitting around a fire thousands of years ago, before electric lights dimmed our view of the night sky, when the stars and moon were constant companions to every human on Earth. On such a night, when the familiar bright moon began to darken and turn red, imagine the mixture of awe, fear, and wonder that would fill your heart. Without the scientific understanding we have today, how would you make sense of such a profound transformation in the sky? Ancient civilizations developed rich mythologies around lunar eclipses, and these stories often shared common themes, despite arising independently across different continents and cultures. Many saw the eclipse as a cosmic battle, with some great force or creature attacking or devouring the moon. Others interpreted it as a sign of divine displeasure or a portent of significant earthly changes. But within these seemingly fearful interpretations, there was often a deeper understanding of the eclipse as part of the natural order of things. In ancient China, people believed that a celestial dragon was attempting to devour the moon during an eclipse. This wasn't seen as a random act of cosmic violence, but as part of the ongoing struggle between the forces of light and darkness that governed the universe. The Chinese developed elaborate ceremonies to help the moon escape from the dragon's jaws, with entire communities coming together to bang pots, drums, and gongs, creating a tremendous cacophony designed to frighten the dragon away. What's beautiful about this tradition is that it worked. Every time, the communities would gather, make noise, show their support for the moon, and sure enough, the bright moon would gradually return to the sky. This must have been incredibly empowering for these ancient peoples, giving them a sense that they could participate in cosmic events, that their actions could influence the great celestial cycles that governed their world. The Vikings told a similar story, but with their own cultural twist. In Norse mythology, the wolves, Skuld and Hati, chase the sun and moon across the sky, and during an eclipse, one of these wolves temporarily catches its prey. The Norse word for eclipse, upsilon, literally means wolf time, and Vikings would shout and make noise to frighten the wolf into releasing the moon. In many South American cultures, the jaguar was the culprit behind lunar eclipses. The jaguar, already a powerful symbol in these societies representing the mysterious forces of the night and the underworld, was thought to leap up from Earth to attack the moon. The red color of the eclipsed moon was interpreted as the jaguar's blood covering the lunar surface, or alternatively, as the moon bleeding from the jaguar's attack. Hindu mythology speaks of the demon Rahu, who was decapitated by the god Vishnu but whose head became immortal. Rahu roams the sky, seeking revenge against the sun and moon, who had revealed his deception to the gods. When Rahu catches and swallows the moon, a lunar eclipse occurs. But because Rahu is only a head without a body, the moon passes through him and emerges unharmed. What's fascinating about all these stories is that, while the specific characters and details vary, they share an understanding that eclipses are temporary events. The moon will return. The cosmic order will be restored. These myths weren't just entertainment. They were ways of processing and understanding a phenomenon that was both magnificent and mysterious. The ancient Greeks, with their developing tradition of natural philosophy, began to interpret eclipses differently. As early as the 5th century BCE, Greek philosophers like Anaxagoras suggested that lunar eclipses were caused by Earth's shadow falling on the moon. This was a revolutionary idea. Instead of attributing the eclipse to supernatural forces, they proposed a natural, mechanical explanation. Aristotle, in the 4th century BCE, used lunar eclipses as evidence for Earth's spherical shape. He observed that Earth's shadow on the moon was always curved, regardless of how high the moon appeared in the sky. Since only a sphere casts a consistently round shadow from every angle, Aristotle reasoned, Earth must be spherical rather than flat. This was one of the earliest examples of using astronomical observations to understand Earth's physical properties, a technique that would prove incredibly powerful throughout the history of science. The blood moon became a tool for learning about our own planet, demonstrating how careful observation of celestial events could reveal truths about the world beneath our feet. Ancient Mesopotamian astronomers, working in the cradle of civilization between the Tigris and Euphrates rivers, developed sophisticated systems for predicting eclipses. They maintained detailed records of celestial events over many centuries, gradually recognizing the patterns that govern eclipse occurrence. Their cuneiform tablets contain eclipse predictions that are remarkably accurate, demonstrating that empirical observation and mathematical analysis could unlock the secrets of cosmic timing. These Mesopotamian astronomers understood that eclipses followed predictable cycles, even if they didn't fully grasp the physical mechanisms involved. They developed complex systems of mathematical astronomy that could forecast eclipses years in advance, knowledge that was both practically useful and politically powerful in societies where celestial events were seen as omens of earthly affairs. The Maya civilization of Central America created perhaps the most sophisticated pre-telescopic astronomy in human history, and their understanding of eclipses was correspondingly advanced. Mayan astronomers could predict not only when eclipses would occur, but also their duration and the degree of totality. Their eclipse tables, carved in stone and recorded in bark paper codices, demonstrate a mathematical precision that rivals modern calculations. For the Maya, eclipses were incorporated into their complex cosmological and calendrical systems. The appearance of a blood moon was connected to their mythology of death and rebirth, seen as a time when the boundaries between the earthly world and the underworld became thin. But this wasn't viewed with fear. Rather, it was understood as part of the natural cosmic cycle that governed all existence. In ancient Egypt, the moon god Khonsu was thought to be battling with Set, the god of chaos, during a lunar eclipse. The red color was interpreted as blood from this cosmic struggle, but Egyptian astronomers also developed practical eclipse prediction methods, incorporating eclipse cycles into their complex calendar systems, and using eclipse observations to refine their understanding of celestial motions. What's remarkable about all these ancient traditions is how they balance mythological interpretation with practical observation. Even when eclipses were attributed to dragons, wolves, jaguars, or battling gods, ancient peoples were careful observers who recognized patterns, developed prediction methods, and passed down accumulated knowledge through generations. Islamic astronomers of the medieval period built upon Greek and Mesopotamian foundations while making their own crucial contributions to eclipse understanding. Scholars like al-Battani and Ibn al-Haytham refined eclipse prediction methods and developed more accurate models of lunar motion. Islamic eclipse observations from this period are still valuable to modern astronomers, studying long-term changes in Earth's rotation. During the Islamic Golden Age, lunar eclipses were understood as natural phenomena governed by mathematical principles. Though they retained spiritual significance as signs of divine power, Islamic scholars developed the concept that scientific understanding and religious faith could coexist, with the natural world seen as a book of divine signs that humans were encouraged to read and understand. Medieval European monks maintained detailed records of eclipses, often interpreting them through the lens of Christian theology, while also recognizing their natural regularity. Monastery chronicles from this period provide valuable historical records of eclipse observations, contributing to our modern understanding of long-term eclipse cycles. The arrival of telescopic astronomy in the 17th century revolutionized eclipse observation, allowing astronomers to study the detailed structure of Earth's shadow and measure eclipse timing with unprecedented precision. But rather than diminishing the wonder of eclipses, these observations revealed new layers of complexity and beauty. Indigenous cultures around the world developed their own unique interpretations of lunar eclipses. Many Native American tribes saw eclipses as times of spiritual transformation, opportunities for healing ceremonies and community renewal. The Hoopa people of California believed that the moon was becoming sick during an eclipse and needed the community's prayers and songs to restore its health. Australian Aboriginal cultures, with some of the oldest continuous astronomical traditions on Earth, incorporated lunar eclipses into their dreamtime stories, complex narratives that connected celestial events to earthly geography, seasonal cycles, and moral teachings. These stories served as both entertainment and education, helping to pass down practical knowledge about eclipse prediction, alongside cultural values and spiritual beliefs. African cultures developed diverse eclipse traditions, often connecting lunar eclipses to ancestors, community health, and agricultural cycles. Many saw the red moon as a time when the spirits of the dead could more easily communicate with the living, making eclipses important occasions for ceremonies honoring ancestors and seeking guidance. What emerges from this global survey of eclipse traditions is a picture of human beings as natural astronomers, driven by curiosity and wonder, to observe, understand, and find meaning in celestial events. Regardless of their specific cultural context, humans have always recognized eclipses as significant events worthy of attention, interpretation, and celebration. The transition from mythological to scientific understanding of eclipses was on to simple replacement of primitive beliefs with advanced knowledge. Rather, it was an evolution that built upon thousands of years of careful observation, pattern recognition, and mathematical analysis. Many ancient insights about eclipse cycles and prediction methods remain valid today, incorporated into modern astronomical understanding. Moreover, the cultural and spiritual dimensions of eclipse observation haven't disappeared with scientific advancement. Modern eclipse chasers often describe their experiences in language that echoes ancient wonder, speaking of transformation, connection to the cosmos, and profound emotional impact. The blood moon continues to inspire awe and contemplation, regardless of whether observers understand the physics of atmospheric refraction and orbital mechanics. Contemporary eclipse events often bring communities together in ways that echo ancient traditions. People gather in public spaces, share telescopes and observations, and experience a collective sense of participation in something larger than themselves. The social dimension of eclipse observation, the shared wonder and communal experience, remains as powerful today as it was for ancient peoples banging drums to frighten away celestial dragons. Modern scientific understanding has also revealed new layers of meaning in ancient eclipse observations. When we realize that historical eclipse records provide valuable data about Earth, its rotation rate, and the Moon's orbital evolution over centuries, we gain new appreciation for the careful observation and record-keeping of our ancestors. Climate scientists use historical eclipse records to study past atmospheric conditions, since the brightness and color of eclipsed moons provide information about volcanic activity, dust levels, and atmospheric clarity. In this way, ancient eclipse observations continue to contribute to cutting-edge scientific research. The blood moon thus serves as a bridge between past and present, connecting us to the long tradition of humans looking up at the sky with wonder and curiosity. When we observe a lunar eclipse today, we're participating in one of humanity's oldest scientific activities, the careful observation and interpretation of celestial phenomena. As we continue our exploration tonight, we'll delve into the specific mechanics of observing lunar eclipses, understanding what modern observers can expect to see and how to make the most of these magnificent celestial events. But as we do, we carry with us the rich cultural heritage of eclipse observation, the accumulated wisdom and wonder of countless generations who have looked up at the blood moon and found in it reflections of their deepest concerns, hopes, and understanding of their place in the cosmos. Now that we've journeyed through the science and cultural history of lunar eclipses, let's explore what it's actually like to witness a blood moon total lunar eclipse, the practical aspects of observation, the sensory experience of watching the event unfold, and how you can make the most of these spectacular celestial opportunities when they occur. Settle in comfortably as we imagine together what it would be like to experience a total lunar eclipse from beginning to end. Picture yourself in an ideal observing location, perhaps a quiet hillside away from city lights, or even just your own backyard with a clear view of the sky. The air is comfortable, maybe with a gentle breeze, and you're surrounded by the peaceful sounds of evening. Unlike solar eclipses, which require special protective equipment and can only be safely observed with proper filters, lunar eclipses are completely safe to observe with the naked eye. In fact, no special equipment is needed at all to enjoy the full majesty of a blood moon eclipse. Your eyes are perfectly adequate for witnessing every phase of the event, from the subtle dimming that begins the eclipse to the dramatic red coloration of totality. This accessibility is one of the most wonderful aspects of lunar eclipses. They're democratic celestial events, available to anyone with a clear view of the moon, regardless of economic status, location, or access to sophisticated equipment. A child looking up from a city street can see exactly the same eclipse as a professional astronomer with a $1 million telescope. The eclipse begins so subtly that many observers miss the initial stages entirely. As the moon first enters Earth's penumbra, that outer, lighter portion of our planet's shadow, the change is barely perceptible. The moon appears perhaps slightly less bright than usual, as if someone has turned down a cosmic dimmer switch just a notch. This penumbral phase can last for an hour or more, with the dimming becoming gradually more obvious as the moon moves deeper into the shadow. During this early phase, it's worth taking time to simply appreciate the normal beauty of the full moon before the main show begins. Notice how bright it appears, how it illuminates the landscape around you, how it makes thin clouds glow as they pass in front of it. This is the moon in its familiar role as the brightest object in the night sky, and soon you'll witness its dramatic transformation. As the moon approaches the umbra, the darker, inner portion of Earth's shadow, experienced eclipse watchers often report a sense of anticipation, a feeling that something significant is about to happen. The slight dimming becomes more pronounced, and careful observers might notice that the leading edge of the moon appears slightly darker than the trailing edge. Then comes the moment that announces the eclipse has truly begun. First contact with the umbra. This appears as a small, dark notch or bite taken out of one edge of the moon. Unlike the gradual dimming of the penumbral phase, this umbral contact is dramatic and unmistakable. The edge of Earth's shadow becomes visible as a curved line moving across the lunar surface. Watching this dark bite grow larger is one of the most mesmerizing aspects of a lunar eclipse. The shadow moves at a steady, predictable rate, fast enough that you can see the change happening in real time, but slow enough that you have plenty of opportunity to observe and appreciate each moment of the transformation. As more of the moon enters the umbra, something wonderful becomes apparent. You can actually see the shape of Earth's shadow. The curved edge moving across the moon is the outline of our planet, projected onto the lunar surface. This is the same curved shadow that Aristotle used over 2,000 years ago to prove that Earth is spherical. You're seeing direct evidence of your home planet's shape, cast in shadow across space onto our lunar companion. The progression of the umbral phase creates a constantly changing tableau in the sky. Depending on the moon's path through Earth's shadow, the dark portion might appear to be taking bites from the top, bottom, or side of the lunar disk. The contrast between the bright silvery portion of the moon still in direct sunlight and the much darker umbral portion creates a striking visual effect. During this partial phase, which typically lasts about an hour, you might notice that the portion of the moon in Earth's shadow isn't completely black. Instead, it often appears as a very dark, red or brown color. This is the first hint of the atmospheric refraction that will create the blood moon's characteristic coloration during totality. Earth's atmosphere is already bending some red light around our planet's edge, providing subtle illumination to the shadowed portion of the moon. As the eclipse progresses toward totality, the bright portion of the moon becomes a smaller and smaller sliver, like a cosmic crescent cookie, with a bite taken out of it. The contrast between bright and dark becomes more dramatic, and the red coloration in the shadowed portion often becomes more obvious. Then comes second contact, the moment when the moon becomes completely immersed in Earth's umbra, and totality begins. This transition can be surprisingly sudden. The last bright sliver of normal moonlight disappears, and the entire lunar disk glows with that mysterious, beautiful red light that gives the blood moon its name. The moment totality begins is often accompanied by a profound change in the observing experience. The harsh contrast between bright and dark is replaced by a soft, uniform glow across the entire lunar surface. The moon appears to transform from a brilliant silver disk into something that looks almost otherworldly, a glowing red orb hanging in space like a celestial lantern. During totality, the moon's appearance can vary dramatically depending on atmospheric conditions and the specific geometry of the eclipse. Sometimes the moon glows with a bright orange or copper color that's easily visible even from light-polluted urban areas. Other times, particularly when Earth's atmosphere contains more dust or particles, the moon can appear as a deep, dark red that's challenging to see without optical aids. The color isn't uniform across the lunar surface either. Often, one edge of the moon appears brighter than the other, creating a subtle gradient from bright orange to deep red. This variation is caused by the moon's position within Earth, its shadow, and the way sunlight travels through different portions of our atmosphere to reach the lunar surface. One of the most striking aspects of totality is how it changes the appearance of the entire night sky. When the moon is full and bright, its light washes out many fainter stars and celestial objects. But during totality, as the moon's brightness decreases dramatically, stars that were previously invisible become readily apparent around the eclipsed moon. This stellar emergence creates a magical transformation of the sky. Constellations that were invisible near the bright full moon suddenly spring into view. The Milky Way, if it's above the horizon and you're observing from a dark location, might become visible for the first time during the eclipse. It's as if the entire cosmos is revealing itself as the moon dims, showing you celestial sights that were there all along, but hidden by lunar brightness. The duration of totality varies significantly from eclipse to eclipse, depending on the moon's path through Earth's shadow. A central eclipse, where the moon passes through the middle of the umbra, can last for over an hour. An eclipse where the moon just barely enters the umbra might have a totality lasting only a few minutes. This variability makes each eclipse unique and gives different viewing experiences. During a long totality, you have time to really study and appreciate the eclipsed moon's appearance. You might notice subtle color variations across the lunar surface, or observe how the moon's brightness seems to fluctuate slightly as atmospheric conditions change. Some observers report being able to see lunar features, the dark Maria, or bright highland regions, even during totality, their contrast enhanced by the unusual lighting conditions. Photography enthusiasts find lunar eclipses particularly rewarding because, unlike solar eclipses, they can be photographed safely with standard camera equipment. The eclipsed moon is dim enough that you can often capture it with the same settings you'd use for landscape photography at twilight. This accessibility means that many amateur photographers can capture stunning images of blood moons without specialized astronomical equipment. As totality progresses, you might begin to notice the first signs that the eclipse is approaching its end. Often, one edge of the moon appears to brighten slightly, indicating that it's beginning to emerge from the deepest part of Earth's shadow. This brightening is gradual at first, then becomes more pronounced as the moon approaches third contact, the moment when totality ends. Third contact can be as dramatic as second contact, but in reverse. The first sliver of bright, normal moonlight appears at the edge of the red disk, creating a startling contrast. After the gentle, uniform glow of totality, the sudden return of brilliant lunar light can be almost shocking to observers who have become accustomed to the subdued lighting. The emergence from totality mirrors the entry process in reverse. The bright portion of the moon grows larger, while the red portion shrinks. The curved edge of Earth's shadow becomes visible again as it moves across the lunar surface, now retreating rather than advancing. The entire sky gradually returns to its pre-eclipse appearance as the moon's brightness increases. The final partial phase, as the moon exits the umbra completely, provides another hour or so of observable eclipse activity. Just as during the initial partial phase, you can watch Earth's shadow gradually release its grip on the lunar surface. The dark bite taken out of the moon grows smaller until it finally disappears entirely at fourth contact, when the moon exits the umbra completely. Even after fourth contact, the eclipse isn't technically over. The moon continues through Earth's penumbra for another hour or so, gradually returning to its full brightness. But this final penumbral phase is often ignored by casual observers, As the change is subtle, and the dramatic portion of the eclipse has concluded, the entire eclipse process, from first penumbral contact to final penumbral exit, typically takes 4 to 6 hours. This leisurely pace is part of the charm of lunar eclipse observation. There's no need to rush, no pressure to catch a brief moment of totality. You can take your time, observe at your own pace, take breaks for refreshments or conversation, and still catch every significant phase of the event. For those who want to enhance their viewing experience, binoculars or a small telescope can reveal additional details during a lunar eclipse. These instruments won't make the eclipse more dramatic. The overall spectacle is best appreciated with the naked eye, but they can show subtle color variations across the lunar surface, reveal lunar features that remain visible during totality, or allow you to observe how Earth's shadow edge appears to ripple slightly due to atmospheric effects. Weather, of course, plays a crucial role in eclipse observation. Unlike some astronomical events that can be partially observed through thin clouds, lunar eclipses really require a clear view of the moon to be properly appreciated. The subtle color changes and gradual dimming that characterize much of the eclipse can be completely obscured by even light cloud cover. This weather dependency means that eclipse chasing, traveling to locations with better weather prospects, has become a popular activity among astronomy enthusiasts. Some dedicated observers will travel thousands of miles to find clear skies for an eclipse, treating the journey as part of the adventure. The social aspect of eclipse observation adds another dimension to the experience. Lunar eclipses often bring communities together, with astronomy clubs, science museums, and parks hosting public viewing events. There's something special about sharing the wonder of an eclipse with others, watching children experience their first blood moon, or listening to the excited conversations of fellow observers. Even in our modern, technologically connected world, lunar eclipses retain their power to create moments of shared wonder and contemplation. Social media fills with eclipse photos and observations during these events, creating a global community of observers, sharing their experiences across time zones and continents. As we near the end of our exploration tonight, we'll reflect on what these experiences mean and how they connect us to the larger cosmos. But for now, appreciate the simple wonder of the eclipse observation experience. The patient unfolding of cosmic mechanics made visible the gentle transformation of our familiar moon into something mysterious and beautiful, and the profound sense of connection to the universe that comes from witnessing these magnificent celestial performances. As our gentle journey through the mysteries of the blood moon, total lunar eclipse, draws to a close, let's take a few peaceful moments to reflect on what we've discovered together and how this cosmic knowledge connects us to something larger and more beautiful than our everyday concerns. Tonight, we've traveled from the basic mechanics of shadows in space to the rich cultural tapestry of human eclipse interpretation, from the precise orbital dynamics that make these events possible to the deeply personal experience of watching our familiar moon transform into something other-worldly. Each aspect of this exploration has revealed layers of beauty and meaning that extend far beyond the simple fact that Earth occasionally casts its shadow on the moon. Take a slow, comfortable breath with me as we settle into these final reflections. Feel yourself relaxing even more deeply, knowing that you've spent these hours expanding your understanding of the cosmos, connecting with the same sense of wonder that has drawn human eyes skyward for thousands of years. The blood moon eclipse, we've learned, is far more than just an astronomical curiosity. It's a visible manifestation of the elegant clockwork that governs our solar system, a demonstration of the predictable yet beautiful patterns that emerge from the fundamental forces of nature. When we understand that the red glow comes from sunlight filtered through Earth's atmosphere, the same atmosphere that sustains all life on our planet, we realize that the eclipse creates a direct visible connection between the cosmic and the terrestrial, between the vast scale of astronomical phenomena and the intimate scale of our earthly existence. This connection runs deeper than we might initially realize. The same gravitational forces that create the precise orbital alignment necessary for a lunar eclipse also influence the tides that shape our coastlines, the stability that keeps our planet's rotation steady, and countless other phenomena that affect life on Earth. The moon that puts on this spectacular show during eclipses has been instrumental in making our world habitable, its presence helping to create the stable conditions that allowed life to evolve and flourish. When ancient peoples looked up at a blood moon and saw dragons or jaguars or cosmic battles, they were responding to a deep intuition about the interconnectedness of earthly and celestial events. While their specific interpretations differed from our modern scientific understanding, their sense that eclipses were meaningful, significant events worthy of attention and interpretation was absolutely correct. The predictability of lunar eclipses teaches us something profound about the nature of the universe we inhabit. In a world that can often seem chaotic and uncertain, where personal and global events can surprise and overwhelm us, there's something deeply comforting about celestial mechanics that unfold with mathematical precision. The moon will continue its patient orbit around Earth. The sun will continue to provide the energy that sustains our solar system, and occasionally these three celestial bodies will align to create moments of transcendent beauty that connect us to something eternal. This reliability doesn't make eclipses less wonderful, quite the opposite. Knowing that we can predict eclipses centuries into the future That ancient astronomers could calculate eclipse cycles with remarkable accuracy using only careful observation and mathematical reasoning reveals something beautiful about both the cosmos and human intelligence. We live in a universe governed by comprehensible laws, and we possess minds capable of understanding these laws and finding meaning in them. The cultural diversity of eclipse interpretations we've explored tonight reminds us that wonder and curiosity are universal human traits. Regardless of their specific historical context, people everywhere have looked up at lunar eclipses and found in them inspiration for stories, ceremonies, scientific investigation, and spiritual reflection. The shared capacity for cosmic wonder connects us across time and culture to a broader human community of skywatchers and meaning makers. Modern eclipse observation continues this ancient tradition while adding new dimensions of understanding and appreciation. When contemporary observers gather to watch a blood moon, sharing telescopes and observations, posting photos on social media, and discussing the science behind what they're seeing, they're participating in humanity's oldest scientific activity, while using the most advanced tools our species has ever developed. The eclipse observation experience itself offers valuable lessons for living. The slow, patient unfolding of the event teaches us about the rewards of careful attention and mindful observation. In our fast-paced world, where we're often rushing from one task to another, a lunar eclipse invites us to slow down, to spend several hours simply watching and appreciating a natural process as it unfolds at its own pace. There's something deeply therapeutic about this kind of patient observation, watching the moon slowly slip into Earth's shadow, transform into a glowing red orb, and then gradually return to its normal appearance, reminds us that many of the most beautiful and meaningful experiences in life can't be rushed. They require presence, attention, and willingness to align ourselves with natural rhythms, rather than demanding that everything conform to our human schedules. The blood moon also offers a unique perspective on our place in the cosmic hierarchy. When we realize that what we're seeing is our own planet's shadow cast on the moon, we gain a glimpse of Earth from the outside, a perspective that's normally available only to astronauts. This cosmic viewpoint can be profoundly humbling and inspiring, helping us see our daily concerns in the context of the vast scales of space and time that govern the universe. Yet this cosmic perspective doesn't diminish the importance of our human experience, it enriches it. Understanding that we're part of a solar system, a galaxy, a universe filled with wonders beyond imagination, doesn't make our individual lives less meaningful. Instead, it connects our personal stories to the grandest story of all, the ongoing evolution and development of the cosmos itself. The atmospheric physics that creates the blood moon's red color connects us directly to the global systems that sustain life on Earth. The same atmospheric processes that bend red light around our planet's edge during an eclipse also create the beautiful colors of sunrise and sunset, distribute heat around our globe, and maintain the delicate balance of gases that makes our world habitable. The eclipse reminds us that we are not separate from these global systems. We are intimately connected to and dependent upon them. This recognition of interdependence extends beyond the purely physical. The eclipse connects us to the long tradition of human learning and discovery, to the accumulated wisdom of generations of observers who have looked up at these events and gradually developed our current understanding of how they work. We're inheritors of this tradition and contributors to it, each observation and insight adding to the collective human understanding of our cosmic environment. The future eclipses that await us offer continuing opportunities for wonder, learning, and connection. Each eclipse will have its own character, determined by the specific atmospheric conditions at the time, the moon's path through Earth's shadow, and the particular circumstances of observation. Yet each will also be part of the same eternal dance, the same cosmic clockwork that has been creating these moments of beauty for billions of years and will continue for billions more. As our exploration tonight comes to a close, I want you to carry with you not just the specific facts and concepts we've discussed, but the deeper sense of wonder and connection that these discoveries can inspire. The next time you look up at the full moon, remember that you're seeing a world, not just a bright disk in the sky, but a complex three-dimensional sphere with its own geology, its own history, its own place in the cosmic dance. When you see the red colors of sunset or sunrise, remember their connection to the blood moon. The same atmospheric processes that create these earthly beauties also paint our lunar companion during eclipses. When you feel the ocean tides, or notice the stable rhythm of day and night, remember the gravitational forces and orbital mechanics that make all of these phenomena possible. Most importantly, remember that you're part of this cosmic story. You're made of elements forged in the nuclear fires of ancient stars. You live on a planet whose stable environment was shaped by billions of years of cosmic evolution, and you possess a mind capable of understanding and appreciating the elegant laws that govern the universe. You're not a separate observer of cosmic events. You're a participant in them, a conscious part of the universe becoming aware of itself. The blood moon total lunar eclipse is thus both a specific astronomical phenomenon and a symbol of something larger, our deep connection to the cosmos, our capacity for wonder and understanding, and our participation in the ongoing story of cosmic evolution. When the next eclipse occurs, Whether you observe it directly or simply know that it's happening somewhere above the clouds, remember that you're witnessing one movement in the grand cosmic dance that connects all things. As you prepare for sleep tonight, or whenever you choose to rest, carry with you the peaceful knowledge that you live in a universe of extraordinary beauty and elegant order. The same forces that create the spectacular show of a blood moon eclipse also maintain the stable conditions that allow you to exist, to wonder, to learn, and to find meaning in your connection to something infinitely larger than yourself. Let the gentle rhythm of cosmic mechanics, the patient orbiting of moon around Earth, Earth around sun, the slow procession of eclipse cycles, the eternal dance of gravity and motion, become a source of peace and perspective in your daily life. These cosmic rhythms remind us that we're part of something timeless and beautiful, something that transcends our temporary concerns and connects us to the fundamental processes that govern existence itself. The blood moon eclipse teaches us that wonder and understanding can coexist, that scientific knowledge enhances rather than diminishes the beauty and meaning we find in natural phenomena. It shows us that patience and careful observation can reveal profound truths about the world around us, and that these truths connect us to both the deepest mysteries of existence and the most practical aspects of living on our remarkable planet. Thank you for joining me on this gentle journey through the mysteries of the blood moon total lunar eclipse. May the wonder and knowledge we've shared tonight bring you peace, perspective, and a deeper appreciation for your place in the beautiful, interconnected cosmos we all call home. Sweet dreams, fellow travelers in space and time. Until we meet again under the starry sky, remember that you carry the universe within you, and you're always part of the cosmic dance, whether the moon is bright silver or glowing red in the gentle shadows of our Earth.